Basics of functions and their graphs preparation. Okay. Now, really quick, let's go up and look at the original one of this, right? The square root. What did the original square root look like? Let's go see. Here's the original square root. So the original square root, you can see it used to go right here where the origin was, right? And then you can see it had a 1, 1, and then it had a 4, 2, and then it had a 9, 3. These points right here, right? You can see all those. Okay, and you can even see where they are on the graph. So let's see if we can kind of figure out how this one's going to be transformed. Okay, it looks like we have both a vertical and a horizontal transformation. So first, we plug in some numbers, right? So we say 3 minus 3, whoops, plus 3. 3 minus 3 is 0. Square root of 0 is 3. Square root of 0 is 0. 0 plus 3 is 3. Got ahead of myself. Next, we have a 4. 4 minus 3, right, plus 3. Square root of 4 minus 3. 4 minus 3 is 1. Square root of 1 plus 3. Square root of 1 is 1. 1 plus 3 is 4. Next, we have a 7. Square root of 7 minus 3. 7 minus 3, oops, sorry. Still have that plus 3 there. 7 minus 3 is a 4. Square root of 4 plus 3. Square root of 4 is a 2, just a plain vanilla 2, plus 3, and 2 plus 3 is a 5. So it looks like we have some ordered pairs here. So we have a 3, can't read my handwriting, 3, 3, and then we have a 4, 4, and then over here we have a 7, 5. Okay, let's graph it and see what we get. So we have a 3, 3. Well, 3, 3 is going to be 3 to the right and 3 up, so we have a point right there. Okay, 4, 4 is going to be 4 to the right and 4 up. And a 7, 5 is going to be 7 to the right. And 5 is going to be 1 up right here. So it looks like what happens is we end up with something like that. Okay, there we go. Now, as far as domain and range go, we can see the domain it's going to start at this point right here, right? That's that point right there. So that point right there is at 3, 3. And we with domain, we care about x. So the x value at that point is a 3. And it just goes off to forever to the right. Now, how about range? Well, range just cares about the y value. But since it's a 3, 3, it's also going to be a 3. And the range is the y. And then it goes up forever and ever and ever. So it is a positive infinity there. And there we go. Okay, let's try the next one. So give each rational function, give the equation of the vertical and horizontal asymptotes. Okay, give the equation of the vertical and horizontal asymptotes. Okay, here we go. Let me plug these numbers in first. So in this case, we're going to have a negative 2 over 1 minus 3. Negative 2 over 1 minus 3 is negative 2. Negative 2 over negative of 2 is just a positive 1, so it looks like we have a 1, 1. Next we have a 2, so it's negative 2 over 2 minus 3, which is negative 2 over negative 1. Negative 2 over negative 1 is a positive 2. Then we do a 3, and this is not going to work very well because we say 3 minus 3, which means we divide by 0, which means this is undefined. Right? So since that's undefined, we've detected something there. Okay, so the next one is a 4. So it's going to be negative 2, 4 minus 3, which is a 1. So negative 2 over a 1. Negative 2 divided by positive 1 is negative 2. Right? And then we have a 5. Whoops. Well, negative 2 over 5 minus 3. 5 minus 3 is positive 2. 2 divided by negative 2 is a negative 1. Okay, here's all the points. So we have a 2, 2, all right? Okay, then we have a 3, but that's undefined, right? Oh no, that's undefined. Okay, we'll explain that a little bit. Then we have a 4, negative 2, and then we have a 5, negative 1. Okay, let's go plot some points. See what this means. So we have a 1, 1, 2, 2. first couple of points. So 1, 1, and 2, 2 go there and there. What about the next couple? Let's see, we have a 4, negative 2. 4, negative 2. And we have a 5, negative 1. 5, negative 1. 5, 5, 5, negative 1. So we have a 5, negative 1 right there. Okay. All right, so let's find out about asymptotes. Now, what happens when we try to divide x by 0, we got it undefined. And where it was undefined was where x is equal to 3. Right here where x is equal to 3. And what that means is x cannot be equal to 3. X cannot be equal to 3. So all along this line right here, okay, where x is equal to 3 right here, that cannot be equal to it, right? So all along this line right here, it cannot be equal to that. That's the equation cannot go through that line right there, okay? And that is going to be a vertical asymptote, right? So that vertical asymptote right there. Oops, well, singular. There we go. Okay, your vertical asymptote. And where is your vertical asymptote? Well, it is at x is equal to 3. That's where it is, right? So that line right there, that red line right there, that horrible red line, that is where it cannot be. Okay, now what about a horizontal asymptote? Okay, well, horizontal asymptote is a little bit different. Okay, so basically what it means is whenever I ask for a vertical asymptote, I'm asking for what values x cannot be, and then that will give me my vertical asymptote. It gets a little more complicated later on, and we'll go over it then, but right now, if it would make it undefined, you're going to have a vertical asymptote. Okay, now the horizontal asymptotes, in some ways they're actually easier to find because there are some rules about the fractions, right? So let's say we have I'm talking about, what you do is you compare their exponent. So this is big exponent, and this is small exponent. So for instance, what if you had, and it's a comparison, smaller, right? So let's say we had this. It doesn't even matter what the rest of this is. If it has a polynomial with more, you don't care. You care about the leading one. So that's a 3, right? And let's say the other one on the bottom is a quadratic, and again, it doesn't matter what the rest of it. It just matters that it has a 2 there, right? This does not have, this is no horizontal asymptotes. So what you do, it's terrible. What you do is you compare the exponent, the largest exponent on top to the largest exponent on the bottom. If the larger exponent, if you have a larger exponent on top and a smaller one on the bottom, there is no horizontal asymptote. Okay? Now let's flip it. What if we have a smaller exponent on the top and we have a bigger, these are really technical terms, bigger exponent on the bottom? Okay? So for instance, what if we just flip the previous one? What if we say, well, x squared on top plus I don't care, and then we have an x cubed on top plus I don't care, or minus I don't care, it doesn't matter at that point. Now when you compare those, what would happen is we have a horizontal asymptote. It does exist. That's a terrible looking horizontal asymptote. And in this case, it's going to be y is equal to 0. Okay. Now notice that actually works on this one right here, in that we have a constant power, and on the bottom we have a power of 1. So if I looked at the powers here, right, so this would be kind of like constant is 0 power, and the bottom has a 1 power. Well, which is larger, 0 or 1? Well, 1 is larger, and 1 is on the bottom. So this is the situation, right? So since we have a larger or more powerful exponent on the bottom, we're going to have the second possibility, right? So that's the first one, that's the second, and then we have a third one, okay? Now in this case, if we scroll up just a little bit, we can actually see where, yeah, it kind of looks like that makes sense. So for instance, right along here, given that theory, sure enough, there is a horizontal asymptote. I can actually go back and finish drawing these. We didn't do this, but I know this right here, this graph is going to approach but never pass that line right there. It's going to, oh geez, it's going to approach, but never pass this one either. I'm not very good at drawing. Okay, so that goes off that way. Same thing on this one is going to go here, and it's going to go up, approach but never touch, go this way, approach but never touch. And sure enough, that confirms what we wrote there for the horizontal asymptote and the vertical asymptote. Now, there's another possibility, right? It could be that your exponent on the top is larger than the exponent on the bottom, or vice versa, the exponent on the bottom is bigger than the exponent on the top. What happens if they're the same? What if the same exponent? Same exponent. Okay, for example, what if I said, oh, it's 2x cubed plus, I don't care, over 3x cubed plus, I don't care. Well, in this case, what you end up with is, I could generalize that more, but in this instance, you'd end up with a 2/3, right? That would be my horizontal exponent would be 2/3, which is made up of the coefficients of your leading coefficients in both the numerator and the denominator. And you would simply make it into a fraction, and then that would give you your horizontal asymptote, right? Okay. We're going to go over this in greater depth later on, but that's just kind of dipping our toe into this right now.